When installing a generator to back up existing elevators and feeding two 200-amp automatic transfer switches for two banks of elevators and one 100-amp automatic transfer switch for the emergency lighting system, with the generator feeders going into Trafford terminal blocks, you absolutely need a disconnect to shut down the emergency feeder, even if there is a breaker on the generator. There are several key reasons for this requirement. Firstly, safety is paramount. A disconnect switch allows for safe and easy isolation of the emergency feeder during maintenance, repairs, or emergencies. It provides a physical break in the circuit, preventing unexpected energization of the feeder, which is crucial for protecting personnel working on the system. Secondly, code compliance is essential. The National Electrical Code, specifically Article 700.12, requires that emergency systems have a means to disconnect all power from the system. This is a mandatory requirement to ensure the safety and reliability of emergency systems. Thirdly, the disconnect switch allows for isolation of the emergency feeder during testing or inspection. This enables thorough testing of the emergency lighting system without affecting other critical loads. You have two primary options for the disconnect switch. First option is to utilize a switch within the generator breaker panel. If the generator breaker panel includes a disconnect switch specifically designated for the emergency feeder, you can use that existing switch. Ensure that this switch is properly rated for the amperage of the emergency feeder and clearly labeled. The second option involves installing a separate disconnect switch. If the generator breaker panel does not have a dedicated disconnect for the emergency feeder, you must install a separate disconnect switch. This switch should be rated appropriately for the emergency feeder's amperage and installed in a readily accessible location. It is recommended to install the disconnect switch in a readily accessible location, preferably near the generator. This ensures that it can be easily located and operated in an emergency. Label the disconnect switch clearly as emergency lighting disconnect. Proper labeling is crucial for quick identification, especially during emergencies. Ensure that the disconnect switch is of appropriate amperage rating for the emergency feeder. The disconnect switch must be capable of handling the full load current of the emergency lighting circuit. Consider interlocking the disconnect switch with the automatic transfer switch for the emergency lighting system to prevent an inadvertent operation. This interlock can prevent the emergency lighting from being accidentally disconnected when it is needed. Choosing the correct disconnect switch is critical. Select a disconnect switch that is rated for the voltage and current of the emergency feeder circuit. The interrupting rating of the switch should also be sufficient to handle any potential fault currents. The disconnect switch should be enclosed in a suitable enclosure to protect it from environmental factors such as moisture and dust. The enclosure should also be rated for the environment in which it is installed. Proper installation of the disconnect switch is also crucial. Mount the disconnect switch in a location that is readily accessible and free from obstructions. Ensure that the switch is securely mounted and that all connections are properly tightened. Use appropriate wiring methods and materials for the installation. All wiring should comply with the National Electrical Code and local regulations. Label all wiring and terminations clearly. Proper labeling makes it easier to troubleshoot and maintain the system. Test the disconnect switch after installation to ensure that it is functioning properly. Verify that the switch effectively disconnects power to the emergency feeder and that it is properly labeled. Documentation is also essential. Keep a record of the disconnect switch installation, including the manufacturer, model number, amperage rating, and location. Include the disconnect switch in the emergency system maintenance plan. Regular maintenance and testing of the disconnect switch are essential to ensure that it is functioning properly. Inspect the switch for any signs of damage or wear. Test the switch by operating it to ensure that it effectively disconnects power to the emergency feeder. The National Electrical Code provides specific requirements for emergency systems, including disconnects. It is essential to comply with these requirements to ensure the safety and reliability of the system. Article 700 covers emergency systems. Article 701 covers legally required standby systems. Article 702 covers optional standby systems. Emergency systems are those systems legally required and classed as essential for safety to human life. Legally required standby systems are those systems required by law or by a governmental agency to supply power to specific types of loads. Optional standby systems are those systems that supply power to optional loads. Article 700.12b specifically addresses capacity of the alternate supply. The alternate supply, usually a generator, must have adequate capacity to supply all required emergency loads. These loads include lighting, power, and life safety systems. The capacity of the alternate power source must comply with Article 700.4, which requires the alternate source to be suitable for the maximum available fault current. Article 700.12b addresses the transfer equipment. The transfer equipment must automatically transfer power from the normal source to the alternate source within 10 seconds upon failure of the normal source. It must also be suitable for the intended use. Article 700.12f concerns coordination. Emergency systems must be designed to minimize the hazards that might result from abnormal conditions. This includes short circuits and ground faults. Article 700.12g addresses the surge protection. All emergency systems must be provided with surge protection devices. These devices protect sensitive electronic equipment from voltage spikes. Article 700.12h addresses system performance. The emergency system must supply power to the connected loads at the correct voltage and frequency. It must maintain stability under all operating conditions. The disconnect must comply with Article 700.12i, which involves coordination with other systems. The emergency system must be coordinated with other building systems such as fire alarm and HVAC systems to ensure proper operation during an emergency. Additional NEC articles also apply. Article 110.3 covers examination, identification, installation, and use of equipment. Article 230.70 covers the location of service disconnecting means. Article 240.21 covers location in a circuit. Article 250.32 covers grounding requirements for separate buildings or structures. When selecting a disconnect switch, consider the following factors. The voltage rating of the switch must be equal to or greater than the system voltage. The amperage rating of the switch must be equal to or greater than the load current. The interrupting rating of the switch must be adequate for the available fault current. The enclosure must be suitable for the environment in which it is installed. The switch must be listed by a recognized testing laboratory. Proper grounding and bonding of the emergency system are essential for safety. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent protective device. Bonding ensures that all metal parts of the system are at the same potential, reducing the risk of electric shock. Use a grounding electrode system that complies with Article 250 of the National Electrical Code. Connect all metal parts of the system to the grounding electrode system. Use bonding jumpers to connect separate sections of metal raceway. Inspect the grounding and bonding connections regularly to ensure that they are tight and free from corrosion. In summary, a disconnect switch for the emergency feeder is essential for safety, code compliance, and ease of maintenance. Choose the appropriate disconnect switch, install it properly, and maintain it regularly to ensure the reliable operation of the emergency lighting system. Always refer to the latest edition of the National Electrical Code and local regulations for specific requirements. When installing the disconnect switch, remember to follow a systematic approach. Firstly, plan the installation. Determine the location of the disconnect switch and the routing of the wiring. Consider accessibility, environmental factors, and code requirements. Secondly, gather the necessary materials. Collect all the materials needed for the installation, including the disconnect switch, wiring, conduit connectors, and labeling. Ensure that all materials are of the correct size and rating. Thirdly, install the disconnect switch. Mount the disconnect switch securely and connect the wiring according to the manufacturer's instructions and the National Electrical Code. Fourthly, test the installation. After the installation is complete, test the disconnect switch to ensure that it is functioning properly. Verify that the switch effectively disconnects power to the emergency feeder. Fifthly, label the installation. Label the disconnect switch clearly as emergency lighting disconnect. Also, label all wiring and terminations. Sixthly, document the installation. Keep a record of the disconnect switch installation, including the manufacturer, model number, amperage rating, and location. Seventhly, maintain the installation. Include the disconnect switch in the emergency system maintenance plan. Regular maintenance and testing are essential to ensure that the switch is functioning properly. Furthermore, when selecting and installing the disconnect, take into account the specific characteristics of the emergency lighting system. Is the system designed to provide illumination for egress routes, critical care areas, or other essential functions? The answer to this question will influence the choice of disconnect switch and its placement. Ensure that the disconnect switch is readily accessible to authorized personnel but protected from unauthorized access. Consider using a lockable disconnect switch to prevent accidental or malicious operation. Coordinate the installation of the disconnect switch with other building systems, such as the fire alarm system and the building management system. This coordination ensures that the emergency lighting system operates seamlessly with other critical systems during an emergency. Train building personnel in the proper operation of the disconnect switch. This training should include instructions on how to disconnect power to the emergency lighting system in the event of an emergency or for maintenance purposes. Keep a supply of spare parts for the disconnect switch on hand. This ensures that the switch can be repaired quickly if it fails. Regularly review and update the emergency lighting system documentation. This documentation should include information on the disconnect switch, its location, and its operating procedures. During the design phase, calculate the load requirements of the emergency lighting system. This calculation will determine the appropriate amperage rating for the disconnect switch. Use appropriate overcurrent protection for the emergency lighting circuit. This overcurrent protection will protect the circuit from damage in the event of a short circuit or overload. Consider using a ground fault circuit interrupter, GFCI, to protect personnel from electric shock. GFCIs are particularly important in wet or damp locations. Use corrosion-resistant materials for the disconnect switch and its enclosure, especially in harsh environments. Conduct regular inspections of the emergency lighting system, including the disconnect switch. These inspections should include a visual inspection of the switch, a test of its operation, and a review of its documentation. Document all inspections and maintenance activities. Maintain a log of all inspections, tests, and repairs. This log will provide a record of the system's performance and will help to identify any potential problems. Stay up to date on the latest codes and standards for emergency lighting systems. The National Electrical Code is updated every 3 years, so it is important to stay current on the latest requirement. Consult with a qualified electrical engineer or electrician to ensure that the emergency lighting system complies with all applicable codes and standards. Finally, remember that the emergency lighting system is a critical component of building safety. Proper design, installation, and maintenance of the system are essential to protect the lives of building occupants in the event of an emergency. A properly installed and maintained disconnect switch is a key element of a safe and reliable emergency lighting system.